Hello everybody, today we will see briefly about quadratic regression in our studio. As all of you know that quadratic regression is one way of checking for nonlinearity in our data, that is to fit the polynomial model and to check whether the polynomial model fits the data better than that of the linear model. However, you may also wish to fit a quadratic or higher model because you have reason to believe that the relationship between the variables is inherently polynomial in nature. So let's see how to fit a quadratic regression or model in our studio. So first, you have to visualize your data, whether it is fit for a quadratic or for the linear one. So to do that, type plot, and before jumping to analysis, it's better to import our data. My data format is Excel, so let's locate the directory, and data name is a quadratic. So I will import to our studio. Then let's see if you want to check the structure, then SOTR, then our data name is quadratic, so it will display two variables. pH stands for planted and grain yield, GY stands for grain yield. So whether the data is fit for a quadratic or not, to do that you have to type this syntax. That means plot quadratic, then attach the dollar, use a dollar sign to attach the plant height or the pH, and as well as here also grain yield. So let's see our plots. As you see here is this downward parabola, so it's not indicate the data is not fit for linear, but it is non-linear. So quadratic regression is better than the linear model for such type of data. So if you want further also to see the statistics, and first let's cross-check between the simple linear as well as the quadratic. So to do that, I love my name. You can give any name that you want. So linear model, then the dependent variable is grain yield. The plant date is independent variable. Our data name is quadratic. So do that, and let's check the summary, what looks the linear model. So summary, and write your name that you fit here. So I wrote work, and so the summary work will give such type of results. Let's maximize it. So as you see in this model, or in this summary, the model only explains, quite unfortunate, this only explains over 4.46 of the variance, and it's not significant coefficient for the intercept and independent variables. So it is not good, because it is the model only explains about what, over 4.46% of the total variance, so it's not as such good. So it is better to fit the quadratic one. So again, if you want to check further to check the linearity by drawing the graph, if you want to do that, so you have to plot, then planted, and followed by grain yield, then is the size, and the y-axis is labeled as grain yield, and also the CX lab is to gives a good axis in both x and y to have good size. Then color is equals to red. So here is error. So to solve this error, you have to type attach. Our data name is what? Our data name is quadratic. So if you run this, the error will be solved. Let's back and click it. Yeah, so the plot is run again. It is downward parabola, and let's fit the linear function. So AB line, then linear model, and grain yield, then followed by planted. The color is blue. So let's see the graph. Yeah, so it is not a linear because it doesn't touch every point, so it is better to fit again the quadratic regression. So in order to fit the quadratic regression, first, as all of you know, that quadratic regression formula is y is equals to x squared plus bx plus c, where a is different from 0, yeah, different from 0. So don't forget to create new variables for the square one or for the planted. So to do that, I assign here is planted 2, which is contain the planted square value. That means x plus b, x plus c, isn't it? So if it is that, it should be the square value by assigning this pattern. So pH2 is the new variables that contain the planted squared value. So run here, let's fit the quadratic regression. WAC 2 is for quadratic regression. So grain yield is followed by planted, and again this means the squared value of what the planted. Then we will indicate our data. Our data name is quadratic. So run this, and let's see the summary. The summary, yeah. Coming to this, over here the model looks very good, and also the model explains over 96.02, and also the models tells that or explains that over 96.02 of the variance and highly significant coefficient for the intercept and for the independent variables, and also it is highly significant overall model of the p-values. So it is very good, and also it is very essential to take the advantage over the linear model. So by this way we can do the quadratic regression. Further, if you want to create to visualize whether the model is fit the data, to do that you have to create a sequence for the planted values by this way. So we will do this one, and again also we will create predicted grain yield level in order to use a quadratic model. To do that, you have to give a name that you want here, then predict, and our quadratic model that we give here is this. Then list is instead of pH value, now the planted is equals to pH values, which is 0, 60, and 0.1. And again here also the pH2 value, which equals to pH value squared value. So you have to do that and run. Then we will create what? The plot. So scatter plot. In order to do that, plot and the quadratic, the planted, and also here is a grain yield or GY. Then this the PC, whether it's star, whether it's dot, or etc. So here is the graphs that are fitted with the quadratic regression. And again, if you to draw a line, so we have to add predict a line based on the quadratic regression model. To do that, lines and pH values and this one. So the pH values, the predicted value, and the color is red that are going to line. So in this way, it also gives a good indication that our data fits the quadratic regression. So if you want to interpret the quadratic regression result, so as all of you know that the quadratic equation is x squared plus bx plus c. So here is the result what we obtain from our analysis is 0.1012. Yeah, it is 0.012, and again here is see here the 0.012, and again we will take also here is 6.4, And again, also here is a intercept value which is equals to negative 18.256. So we have to analyze. Let's take an example. If the plant height is 60, here is the equation. So it will be yield around 22.09. While conversely, if you take the plant height 30, it will take here is 3600 is 60 by making 60 square. So you have to understand it this way. And if you take an example, is 30 here the plant height, 30 square is 900. So we will get around 92.99. So this is all about the quadratic regression. If you have any question regarding to my tutorial, you can address me through my email wabjiratesfan@gmail.com, or you can also use the YouTube comment box for your questions. Thank you for watching and have a nice time.